Good morning, it's Sid here from Border Archery. Quick one really about, there's a conversation I've just read about stored energy, and some of the numbers looked a little bit high from what I can see. Rule number one, really simple, measure at 28, okay, because then everybody's got comparable numbers. You get bigger numbers if you go longer draw lengths, you get smaller numbers if you go for smaller draw lengths. And the idea is quite simple. You're looking for the area under the graph, the total amount of energy in the system. Okay? And the simple way to calculate it would be to add up the poundages at each inch. So at the first inch of draw, 8 pounds, second inch of draw, 12 pounds. So you add the 8 and the 12 together. Okay? But the reason why I'm saying that the calculation's wrong by simply adding them together is because you end up with a slightly over-exaggerated stored energy. Most spreadsheets that I've seen posted online have had this exaggerated energy level. So what the most simple trick I've seen, I will explain. Okay, so if you have a draw force curve that's 1, 2, 3, 4 and 5, okay, you effectively have got a straight line, 1 pound gain for every inch that you've drawn the bow, starting at 1, ending at 5. And if we added them up, we would have 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus the last one, 5, being 15 inch pounds of energy. You divide that by 12, but either way, I'm not going to do that yet. So in this calculation, you've got 15 inch pounds of energy. But what you've essentially got is a right angle triangle. And the right angle triangle maths would mean you've got 5 inches of draw and you've got 5 pounds of holding weight. And if you do a right angle triangle of 5 times 5, which is, 5 times 5 divided by 2, would give you 25 divided by 2 would be 12.5 inch pounds of energy. Now, a 5 pound bow with a 1 pound gain, straight line, doing the triangle maths gives you 12.5, but by adding up the 1, 2, 3, 4 and 5, you end up with 15. As I say, you end up with an over-exaggerated value. So, the way to do this in the most simplistic manner, without going into any more complicated maths, but the most simplistic manner is just half the last value. So, in the case of the 1, 2, 3, 4, 5, the 5 would be the last value. Half that would be 2.5. So, it would be 1 plus 2 plus 3 plus 4 plus 2.5. That means your 15 would be 2.5 less, giving you 12.5, which means it's the same as the triangle. This takes you within decimal places of accuracy of the real value if you were to use more complicated methods of doing the maths. Really quite simple. Half the last value. So if you've got a 40 pound bow, don't add the 40 at the end. So it'll be 36, 40. Don't add that 40, add only 20. And you get yourself a much more accurate answer when it comes to stored energy. Okay? Now just remember, at 28 inches, you can divide the stored energy by the holding weight. And that will give you your stored energy per pound held. And that's quite a funky number. That allows you to compare two different bows and come up with the same comparable answer. Okay? So that's how that works. If you've got any questions, ping them in the comments and I'll do my best to answer. All right, but that's how you can compare designs. Now 0.92 is a good value for a ILF recurve, for a conventional recurve. Okay, we currently sit with 0.96, 1.1 and 1.17 for our ILFs. for the 2, the 5 and the 9. And if you go up again to the hex 9, we've got 1.26 stored energy. We're not shy of our stored energy. We've done our homework. We know exactly where we stand. And that's where the performance should come from. Okay? So the 0.88 would be a good competition longbow. Flat bow for the Brits. And 0.92 would be good for 0.9192 would be good for a top end well designed recurve. Alright, super recurves are a different league. Alright, thanks for watching.